Okay, so at the instance show, I got a 3,000 pound car traveling at a speed of 75 feet per second, increasing. So basically, I'm hitting the accelerator and increasing the rate at 6 feet per second squared. And I want to find the total friction force rode on the tire. So again, here's what we've got. This guy has a tangential in this direction, okay, and normal in this direction, okay. And a lot of times I set this up after I draw my forces, but again, I recognize I'm going around this curve. Okay, it gives me a radius, so I'm going around that curve. So I got a tangential and a normal component. And what happens is me stepping on the gas or whoever's doing it causes a friction force in the tangential direction, right? The tires basically push against the road and speed it forward in that direction. Now, as I go around the curve, turning the wheel, the road's pushing against the car and it pushes the car in that direction. Now, there's a Z coming out of the screen, right? I've got a weight and a normal force, but we don't really care about those at this point. We're just really looking for those friction force, the normal and tangential friction forces. So we're not going to worry too much about the Z axis here, unless we need to, okay? So I'll start by summing the forces in the tangential direction, where all I have is the friction, right? And then its acceleration. Well, this is a 3,000 pound car. So I take that 3,000 pounds, I divide it by 32.2 so I can get it into mass times its acceleration in the tangential direction, which is given to me to be 6. Again, this is another reason why we set up our axes based on what we know about acceleration. I know it's tangentially accelerating, so I can just very easily write that um, acceleration in that direction right like that. Okay. Uh, do the same thing in the normal direction, where again, the only force I've got is the normal um, friction, pushing it towards the center, making it go around the curve there. Okay. And then that's going to equal the mass times its acceleration in that direction, where the mass again is 3,000 divided by 32.2. Got to convert from pounds to slugs. Okay. And then on this one, the normal acceleration is v squared over rho, where v is 75 squared over rho, which is given to me to be 600. Okay. So what I have here is I can very easily find the tangential friction, 559 pounds, the normal friction, 873 pounds. Okay. But what it's asking me to find is the magnitude of the friction. So the magnitude is going to be the square root of the sum of the squares. So the total friction, which would be, in this direction, some amount, I just take the square root of the sum of the squares. So I take the 559 squared and add it to the 873 squared, take a square root, and I get the total friction, 1,037 pounds. Okay, so again, free body diagram, set up your axes based on what we know about acceleration, and then go ahead and use your general motion equations and solve for what you're trying to find.